2, 1. Good morning, afternoon, and evening, everyone. Welcome to Cassandra Lunch 121, and happy December. Today, we're going to have Obi presenting Migrating to Azure Managed Instance for Apache Cassandra. The hosts for this event are Raul and myself. We are looking for speakers and sponsors for this event. If you're interested in either opportunity, please reach out to me at the email listed below. We here at Anant, we are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally surrounded around data. You can find out more about these different groups at the links listed below. What do we cover here? Well, we cover everything related to Cassandra, Spark, Kafka. We do have a huge library related to all these topics, so please take some time and go through some of our previous Cassandra videos and check them out. If this is your first time attending a Cassandra lunch, please leave your name, how you work with Cassandra in the chat, and what you're hoping to learn from these lunches and from the community, and just go ahead and introduce yourself. Group rules: if you have a question, ask it. I'll defer to Obi for when he likes his questions asked. If he likes them asked in the break during the presentation, please be respectful of that and just leave them in the chat and I'll pass them along. Also, please be polite and courteous to others, like we mentioned earlier. And obviously, we want everybody to share what they know, so this is interactive for everybody. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So you could say Cassandra is our bread and butter. As I mentioned earlier, we'd like to thank some of our program sponsors listed here as well. Also like to thank our organizational sponsors. And then I also wanted to open up the chat to any announcements you may have, any jobs, meetups, hackathons, conferences, or classes you have coming up. Please leave a description and or a link in the chat below. And we are hiring full-time and part-time positions here at Anant. If you're interested in or want more information on some of these available positions, please visit careers.anant.us. We do have some events coming up. Please visit our website for more detailed events. We host our Apache Cassandra lunch every Thursday at noon Eastern, and our data engineers lunch every Monday at same time. Also, please do check the site because we have some interesting lunches coming up for the month of December and heading into the new year. And also, like I mentioned earlier, we do have a vast library of Cassandra videos covering a full range of topics. So please subscribe to our channel if you haven't already, and check out the videos we have there and some of the ones we have upcoming. Also like to point you towards Cassandra.Link, which is curated by the team here at Anant. It has resources by all sorts of Cassandra resources that we put together. It's very useful. It's linked there below. Please do check it out. And then finally, our latest Apache Cassandra Runbook 11 is out. This edition covers the copy command and useful no tool commands. Please download your free edition of that while it's still available. This will be gone soon, so please do download your copy while it's still available. And with that, I'll hand it over to our presenter for today, Obi. Obi, over to you.
All right, thanks, Akwi. Give me 1 second to share my screen. All right, it should be visible. As you heard, I'm Obioma Anomnachi. I'm an engineer here at Anant. Today's topic is going to be on migrating to Azure Managed Instance for Apache Cassandra. I generally prefer to take questions during breaks in the presentation, but since this is since the only available venue for asking questions is the YouTube chat, just during breaks, I'll ask Akwi if there are any questions or comments in the chat. So what we're going to be talking about today is the different suggested ways for migrating data from some sort of on-premise Cassandra or potentially a separate cloud Cassandra into Azure Managed Instance for Apache Cassandra. Some of these methods also work for Cosmos DB Cassandra API because that is compatible with Cassandra drivers and Spark Cassandra connector. But some of them do not work for Cosmos DB. And we'll talk about that a little bit when we get to the difference. But the important thing to keep in mind there is that anything that involves hybridization, hybrid clusters, or anything like that is not going to be possible with Cosmos DB because it's a completely separate system. But potentially Azure Managed Instance for Apache Cassandra can bridge that gap. Can form hybrid clusters with your on-premise Cassandra, and also communicate with Cosmos DB. So first, what is Azure Managed Instance for Apache Cassandra? It's the Azure hosted Cassandra. It's a managed service, comes with Azure security as one of its main selling points. It has automations, includes automations for repairs and updates, things like backups and recovery. Automations for scaling your clusters, and then integrations with existing Cassandra tools, like it still works with CQLSH, it works with drivers. You can potentially connect some metrics tools like Prometheus and Grafana in the same way you would an open source Cassandra cluster. And it's both compatible with Cassandra clusters that are elsewhere, but also compatible with Cosmos DB Cassandra API. All right, so the two main migration methods that we're going to be contrasting here are using Apache Cassandra native replication. Basically, what that means is make a hybrid cluster between your existing Cassandra cluster and your Azure Managed Instance Cassandra cluster. So one data center, that's your on-premise, and one data center, that's your Azure Managed Instance. And then Cassandra's existing cross data center replication policies, gossip and things like that, will move your data from one to the other, make sure they are in sync. And then the other main one that we're going to be talking about today is using the Azure Cassandra Migrator to do an offline migration. So there are also methods that are meant for doing live migrations. You can use change data capture tools. There are other things that we'll get to after we compare these main two, but since these are the main recommended beyond, a paid CDC program that Azure recommends, then these are the main two that we're going to talk about today. So the differences that we're going to get into are, which external tools you need, whether your clusters are separate or combined, and then other things that are being connected and the process is being run, what they're useful for as well. So the hybrid cluster replication method. So you have your cluster on premise. You're going to extend that with a new data center that's on Azure in Azure Managed Instance for Apache Cassandra, and then let Cassandra's cross data center replication move data onto the Azure data center. Apache Managed Instance for Azure Managed Instance for Apache Cassandra has some requirements. So node-to-node encryption needs to be enabled on your on-premise database because it's always enabled on Managed Instance for Apache Cassandra. You have to upload your certs to Azure Cloud Storage. And there are also some quirks of Azure Managed Instance that we have to take into account, like SSL being enabled by default, and things like not having any external IP addresses. And so needing tools in the same VNet. All your tools for connecting to your cluster has to exist in the same Azure virtual network as your cluster itself. So the steps generally for setting up this replication is going to be to create your virtual network and configure a subnet for it, and then add the extra permissions that are needed by Managed Instance for Apache Cassandra, which is something a network resource or something like that. You're adding a specific role onto this virtual network that all managed instance clusters need to actually come up on Azure within that VNAT. And then you create and configure the resource for Azure Managed Instance. And once that comes up, you can move your certs over and install them. Well, to get the resource to come up, you have to take your certs for node-to-node encryption from your existing cluster and put them in Azure. So they have to go into cloud storage on Azure so that you can create your managed instance cluster. And then you need to take the gossip search from your new Azure Managed Instance cluster and install them back in all your nodes in your existing data center. And then you can create a new data center and have that data replication start to take place. And then in contrast, the Azure Cassandra Migrator method is to run a Spark job that's going to copy data from an existing Cassandra instance of any type to the Azure Cassandra instance. Obviously, this requires you having a Spark cluster. Azure recommends that you use an Azure Databricks cluster and Scala notebooks. We're actually going to look into the code for that a little bit later. But if you can configure all of the network stuff properly, it's also possible to use standalone Apache Spark, potentially running in an Azure VM. And you also don't need the Scala notebook. Obviously, standalone Apache Spark can't actually process that. That's part of Databricks. But you can use Spark Submit to run the same job. And we'll look into the differences between notebook running and Spark Submit running as well a little bit later. And then the Azure Cassandra Migrator, it's Scala code. The jar is available in the repo that we're going to look at a little bit later. But it's basically a modification of the Scala Migrator code. It has readers and writers that are Cassandra specific. It lacks some of the stuff that Scala Migrator has, like anything relating to DynamoDB, because it's meant specifically for Cassandra to Cassandra. And then it has different defaults to the Scala Migrator as well to take into account what the security looks like on your standard Azure managed instance for Apache Cassandra cluster. And then it also has some more more technical differences. TTL and write time are treated slightly differently from your Scala Migrator. It has this setting called min TTL that will create your data in the new systems with a minimum TTL. And then it runs into some of the same problems as Scala Migrator if your data is not how it wants it to be. So specifically, there are issues with preserving write time and TTL for collections, but that's really a Cassandra issue. That info is in the SS tables, but not accessible via query. So it's hard to migrate it. And then other issues that sort of result from that, basically in dealing with TTL and write time. So before we go into looking at the code, let's talk about some of the other methods that you might be able to potentially use. And we'll do a little bit of compare and contrast on our methods from before and these methods. So Kafka Connect. Really, this is just a stand-in for any sort of streaming based setup that you might want to concoct, but Kafka Connect can actually do a lot of the work for you. Basically, what you're doing is you load data from your existing cluster into a Kafka topic, and then you load that data into Azure Managed Instance using Kafka Connect and a Cassandra sync, using your Azure Managed Instance or Apache Cassandra as that sync. The dual write proxy is a live migration method. It doesn't cover any historical data transfer, but it means that when application data is coming in, it gets written to both the old cluster and the new cluster, and it basically sets up your timeframes for your migration so that historical migration that has to happen is only for a set time frame. You don't have to necessarily do things like delta migrations, or and then sort of the opposite of that is change data capture, which is basically constantly doing delta migrations. So basically a CDC tool, like I believe the one that Azure recommends is Arceon, but it's a paid tool with CDC capabilities. Basically, it pulls a stream of deltas from your source DB, pushes those changes to the target, so that it's essentially constantly keeping track of changes and pushing them to your target DB. So some of these methods only work for live migration, and some of them can also potentially do historical migration depending on how it's set up. And you sort of see that difference in these methods as well, because your hybrid cluster replication migration is going to basically be doing dual writes. Because it's two data centers, if data is written to one but not the other, it will replicate across. So you essentially have this timeline for dual writes, but also it replicates any data that was already there and keeps them in sync. But if you want, all your applications, of course, are still reading from your old on-premise cluster. So you would indeed have to switch those over before you could decommission the data center from your on-premise Cassandra. And then the Cassandra Migrator is, of course, your pure offline migration. It transfers a set amount of historical data. And if you look at the sort of migration timelines that something like the zero downtime migration is sort of implies, they will often have a step in the middle. Once your dual write live migration tool is set up, then you have this time frame where this sort of thing, your Spark run or however you're planning to do it, offline migration is running. And then when that completes, you verify it, verify that the source and the target match, and then you can switch your application over and decommission the old cluster. All right, so in a little bit, we're going to go through a demo. I had planned to have a demo going through both of these, the two main methods, but I had a lot of trouble with the Azure infrastructure this morning. So nothing is currently set up for that. Instead, what we are going to do is we are going to walk through these guides, and I'll tell you where I had trouble and how far it got and stuff like that for each one. And then we're going to have a quick look through of the Cassandra Migrator. Well, I was going to say the repo, but really we're going to look at the migrator code itself, because the other important stuff in the repo is all contained within this tutorial here. So first, pausing for any questions. Anything in the YouTube chat?
No questions so far.
Okay. Okay. So first, we're going to talk about making your hybrid cluster. So the prerequisites that it wants you to have set up, they don't talk about it here, but obviously you need node-to-node encryption enabled on your, they talk about it later in this article. And of course, these links are going to be in the resources section here. Once this slide goes up SlideShare, so they'll be accessible via the blog post. And also expect some sort of forthcoming of those examples. I'm not sure what the format's going to be exactly, whether it'll just be a blog post with screenshots or whether it'll be another Cassandra Lunch later down the line where we go through those demos. But they'll show up eventually. So for this, I use the Azure Cloud Shell rather than installing Azure CLI locally, which this talks about. Your Azure virtual network needs to have connectivity to your on-premise environment. That if you're just using a regular internet connected device isn't super difficult. So the first thing they want you to do is create your virtual network. So part of the issue with this is that the virtual network that you find in Azure when you search virtual network creates something called the Virtual Network Classic, which is not compatible in the same way with Azure Managed Instance for Apache Cassandra. So I found that the best way to do this is actually to skip this step here, where you create the virtual network, and go immediately to trying to create the cluster. This is going to fail, but the part that creates your virtual network will succeed. And then you can then use that VNet and subnet and go back to do this. So here in between, so after you've created your virtual network, even if it's through this circuitous process, you need to add the specific role that managed instance for Apache Cassandra requires, which has to be done through the Azure CLI. I have not found a way. It uses these specific assignee and role what do you call it, placeholders, and then it creates a role under your VNet for, it will say Cosmos DB, but it works for the permissions for managed instance or Apache Cassandra as well. And then you need to create and configure the resource. So what they have you do here is they have you set your resource group name, cluster name override in case your actual Cassandra cluster name is illegal as a name for a cluster in Azure, and location and your subnet ID. So this is your full subnet ID. It's basically the end part of the URL that points to that subnet. So your subscriptions, subscription ID, your resource group name, your VNet name, and then the subnet name. So it refers to the specific subnet that you created earlier. And then you create a cluster using the using the command. You need to include what is the seed nodes for your external cluster, and then what are the certs used for gossip in that external cluster, as well as if you have client node encryption turned on, you need to provide those certificates as well. That isn't actually required, it's optional. You can have node-to-node encryption turned on without having client-to-node encryption turned on. And then you can pull details from your cluster before creating your new data center. Here. So basically you use the AZ Managed Cassandra resource create or cluster create here, but it creates a cluster without any data centers in. And then this down here will create data center. If you use the, you can't actually use the Azure Managed Instance form to create this hybrid cluster version. But if you were to use that form to create a cluster, you create a data center, at least one, during that process. But in this case, you create your cluster and you create your data center separately. And then once your data center is created, your replication will start. But I believe then you also need to put this new data center seed nodes back into your Cassandra YAML file on the on your other nodes, as well as the certificates. And then the way that they want you to actually do the migration here is create your hybrid cluster using those instructions above. Disable automatic repairs, which is this command. And then use node to rebuild on every node in your new cluster. And then you can move your application over once that replication has completed. And then you can take down your old, run node to decommission on your old data center, switch your application code, and then re-enable repairs. And then you should be good and done. And then the timeline or the instructions for doing this offline migration with Apache Spark. You're not going to create a hybrid cluster, so it's generally easier. You just need some VNet provision. This skips all of the creation of your actual Azure Managed Instance cluster. But essentially, you can just create that using the dialog. One thing is that you need to move over. This does not transfer schema, whereas the other one does. So you need to move over your schema beforehand. And of course, managed instance for Apache Cassandra on Azure does not have external IP addresses. So in the instance that you need to connect using CQLSH or something, you're going to need to have an extra VM up in your Azure in the same virtual network that can communicate with your cluster with CQLSH. And there are some details in doing that in this link here. So the first thing they want you to do in this, assuming you already have your old Cassandra cluster, your new Azure Managed Instance for Apache Cassandra cluster, and all of your networking stuff handled, and your key space table schema moved onto your new cluster. They want you to create a Databricks cluster. So the one that they want you to use, they want you to use a specific version. So it says Spark 3.0. So I believe the original, or at least the version that's out now, the version of the Skillet Migrator, unless it has been updated since then, wants you to use some version of Spark 2.4 for compatibility, and the updates for that to move to Spark 3 have not released yet. But the Cassandra Migrator, I believe, does not have this issue and is compatible with Spark 3. I want you to update your Cassandra configuration. These essentially are options that your migrator is going to use when it connects and starts sending data. So you're basically setting the defaults here rather than having them set elsewhere. All right, so this is, here we go. So they have you pull the jar file from Maven, this Spark Cassandra connector, the version that's needed for the Cassandra Migrator. If you look at the top level, Skillet Migrator actually is pulling in Spark Cassandra connector already. But if you look at the top level of the Cassandra Migrator repo, it's not being pulled in here. So they want you to import that, that package. And one other thing that you'll notice is that if you're looking at the Skillet Migrator, there are no package jars in this repo. They want you to build it, which is why they've made sure to include all the dependencies. Whereas the Cassandra Migrator, if you look into this jar directory, there are some pre-built jars. So the 0.001 version, which hasn't been touched in like a year and a half, as well as the 0.0.3 that was updated about 6 months ago. And you can use these jars this is the wrong page again. I'll just actually close that one. All right, so once you have imported everything that's necessary there, they want you to create a Scala notebook to do the actual migration. So if you ever use Scala Migrator, you'll know that the way that that information is usually passed in about what your source is, what your target is, all the options for the migration, those are passed in via config file when you run the Spark submit. Whereas what this Scala notebook is doing is it's actually creating the Scala objects that would be created from those config files and then using them to run the process. So you'll see what's happening is they're creating a map with all these values for your Cassandra source and your Cassandra target, which is going to be Azure Managed Instance for Apache Cassandra. If you'll notice, it has a bunch of these extra options. And we'll get a little bit more detail when we're going through here in a second. And then you call this to read data from your source and write it to your target. Okay. So looking at the instructions in the actual repo, they're a little bit more detailed. This one tells you about uploading the proper jar file, which was not in the first one. They told you to get Spark Cassandra connector and install it, but not to load in the actual jar file. And then messing around with the throughput settings that affect how fast your migration takes place, how much data can be written and read at any given time. And then here, we'll see it goes into a bit more detail about what your notebook maybe should look like. So comparing it to this, when you create your Cassandra source here, you give it an IP, a port, username, password, whether SSL is enabled or not, and then a key space and a table. But what's actually required to do any sort of actual migration to Azure Managed Instance, because there's going to be SSL enabled, and you'll need to give details on that. There's going to be encryption, and all that stuff needs to be taken into account. So here, assuming your source does not actually have all of those things enabled, because they don't need to be, Spark is actually doing the connection. So you can actually have SSL off on your on-prem, and then SSL defaulted to on your Azure Managed Instance, and still be able to migrate data. But you still have to make sure you're providing some value for these SSL options so the code doesn't lock up. You still give the same IP, port, username, password, in this case, data center name, key space table, and then options that determine how fast this stuff happens, split count, connections, fetch size. This is actually something that isn't detailed in the tutorial, but if you use Scala Migrator, you can use this where option to filter code on your input side to determine what actually needs to get written into your target. And then you create your source DF using that option. And then the actual migration to Cassandra takes place. You need, of course, the writers as well. So a bunch of the imports are up here. Imports that are needed here. It shows Spark Cassandra connector, CQL stuff, Spark context, and then also you need the readers and writers. So in this case, you're taking the writers from the Scala code. because you're going to incarnate one down here. Specifically the Cassandra writer, and then use its write data frame method to write data to your target. So you create the same, you've created your source definition. Now you create your target definition, the same as SSL options need to be passed in. In this case, it tells you which algorithms it's set up to use. You still pass in the same key space table name. And then this option, strip trailing zeros for decimals. There's a sort of quirk with Cassandra that can result in your decimals coming in with like a bunch of trailing zeros at the end. So 0.200000000. And basically, if this detects that, it just strips it down to the actual significant figures. And then you can call write data frame. And so all this is supposed to be taking place in your Scala notebook, which will run and then copy data out of your source into your target. Like I said, you can also run this via Spark Submit. And then this, the Scala Migrator, and therefore the Cassandra Migrator also includes this validate option. So rather than running, in the end, you'll see what you run here is Cassandra.read data frame and writer's Cassandra write data frame. In the validate, you set up sort of the same way, your source and your target, as well as a validator config. So you use your defined Cassandra source and target, and you run validator.run validation. And you hand it all of that config information, and it tells you if there are still mismatches in your data. So if you look at the actual build files, which is something that we were going to do. So these main folders of what actually gets built, you can see they sort of have the same format. Connectors, migrator, validator, connectors, migrator, validator. Scala Migrator also includes support for Dynamo. So it has this extra code that helps connect to Dynamo. And then if you look inside, so these should be mostly the same, the config. Looks like Scala Migrator also has AWS credentials type, which Scala Migrator wouldn't necessarily need. Or sorry, Cassandra Migrator wouldn't necessarily need. But if you look into the readers and writers, that's where you're going to see the real difference. So Cassandra.Scala exists in both. But then if you look into the writer, Scala Migrator is going to have a Scala writer, which can indeed be used to write to Cassandra. But the Cassandra Migrator has another Cassandra source here, the Cassandra writer, Cassandra.Scala. If we look into the writers here, Scala and Dynamo, and no Cassandra writer specifically. But Scala and Cassandra are compatible enough that this code is still nearly identical. Just a bit of difference. And then in the readers, you can read from Cassandra, but the Scala Migrator also has readers that will read from a Parquet file or read from DynamoDB. So getting your source data, you can get data from a number of different places in Scala Migrator and potentially write to something like DynamoDB, which Cassandra Migrator can't connect to because it's more specialized specifically for migrating from Cassandra to Cassandra somewhere else. All right, any questions in chat now? Okay. So that is about all I had today. Like I said, I ran into issues getting my demos set up for today, but expect that to be forthcoming in the future. And then the various methods, you may also see comparisons of these methods here with Kafka Connect or the dual write proxy or CDC, if I can find a free CDC tool, or one that has a demo. But yeah, so those are forthcoming in the future. But today we just covered what are these main migration methods and sort of what are the differences between them.
Thank you, Obi. We'll be looking forward to those resources you mentioned. They will be linked to this video in the description once they are prepared. Obi, I want to thank you again for a fantastic talk as always. I'd like to thank everybody as well for joining us. We'll be here same time, same place next week. But also please do visit our events page for an updated look at the events we have coming up in December, because we do have a few cool talks I think you will enjoy. And if you haven't, please download your free runbook while it's still available, and subscribe and like the video if you haven't already. Thank you, everyone, and we'll see you next week. Take care. All right, and we are